Now our next example of a composite figure is a little more intense because we don't have every measurement we need to dive right in and start solving them. In this example, I'm looking at a rectangle with a triangle attached. I could break it down into more pieces if I want. I could see perhaps a rectangle coming out to here and two triangles attached to it as well. I could even break this down and see it as two trapezoids. Either way, the information provided, 22.5 meters, 37.5 meters, 75 meters, and 62.5 meters, is not sufficient to get to an answer immediately. I'm going to have to do a little bit of work to get me there. So I want to always ask myself, what more can I find with what's provided in the problem? If I drop that altitude down, I can see that this 75 is broken into two parts. One part being 37.5, and another part being 37.5. So that's been broken in half. Now that's because this 37.5 comes down, creating a rectangle here. Subtract the 37.5 from 75, and there's the other half. Now that'll let me find this area right here. And that's not too bad. The area of any rectangle I know is going to be base times height. And that's going to be 22.5 times 37.5. And that area is going to be 843.75. The next step I need to look at has to do with coming up with the area of this triangle here. Now the catch is I don't know the height. I know this height is 22.5, but I don't know the whole height. I do, however, have the slant over here and the base of 37.5. So if I think about some of the things I know that will help me find the missing side in a triangle, the problem gets a lot easier. I'm really looking at a Pythagorean theorem problem. A squared plus b squared equals c squared. So what I can do now is plug into that and figure out my missing side, which would be the height of this triangle. So I put in 37.5 and 62.5. And now I can go ahead and solve that. I'm going to square it, subtract it, and take the square root. When I'm done with the Pythagorean theorem, I'm going to get an answer of 50. Now I can go ahead and get the area of that triangle. So 1/2 base, which in this case is 37.5, times the height, which I got is 50. Put those all together, and you end up with 937.5. Now these units are all in square meters. My last step is to bring these two areas together. Area of the box plus area of the triangle will give me the area of the entire composite. Adding these together, I get 1781.25 square meters. So again, if I look back to the problem, I didn't have everything I needed to begin, but I did have the tools necessary, specifically the Pythagorean theorem, to get that one missing piece. That piece being this height here of 50. Once I have that using the Pythagorean theorem, I can then apply the rule for the area of a triangle to go ahead and get the area of that triangle. Add the area of the triangle to the area of the rectangle. There's the area of my composite figure.